Hey everyone, and welcome back to the channel. Today we're diving into one of the wildest places on Earth, Yellowstone National Park. You've probably seen those incredible pictures of geysers shooting water high into the air and those stunning rainbow-colored hot springs. But have you ever heard the claim that the water in some of Yellowstone's geysers is a scorching 370 degrees Fahrenheit? That's almost twice the boiling point of water. It sounds completely insane, right? Like something out of a science fiction movie. How could water possibly get that hot without just turning into steam and disappearing? Well, today we're going to debunk this myth. Or are we? Because the fascinating truth is, it's not a myth at all. The water really can reach those temperatures, and the science behind it is way cooler than you might think. Stick around because we're about to take a deep dive into the mind-bending physics of Yellowstone's plumbing system. So let's start with what we all learn in science class. Water boils at 212 degrees Fahrenheit, or 100 degrees Celsius, at sea level. You put a pot of water on the stove, it hits that temperature, and it starts bubbling away into steam. Simple. So how on earth does Yellowstone break this fundamental rule of physics? The secret isn't in the water itself, but in the immense pressure it's under. Think of it like a giant, natural pressure cooker buried deep beneath the ground. Yellowstone sits on top of a massive volcanic hotspot, a chamber of molten rock or magma that heats the entire region from below. Rainwater and snowmelt seep deep into the earth through cracks and fissures, creating a complex underground plumbing system. As this water gets closer to the magma chamber, it gets heated to extreme temperatures, far beyond the normal boiling point. But here's the crucial part. This water isn't just sitting in an open pot. It's trapped thousands of feet underground, with the weight of all the rock and water above it pressing down. This immense pressure physically prevents the water from boiling, even when it's superheated to over 300 or even 400 degrees Fahrenheit. Imagine trying to open a can of soda that you've shaken up. The pressure inside is so high that the carbon dioxide stays dissolved in the liquid. The water in Yellowstone is similar. The pressure is so intense that the water molecules are squeezed together, unable to expand and turn into gas or steam. They're basically trapped in a liquid state, holding a massive amount of thermal energy. This is what scientists call superheated water. It's water that's hotter than its boiling point but remains liquid because of extreme pressure. Now for the spectacular part, the eruption. This is what happens when that pressure is suddenly released. Deep underground, the superheated water continues to get hotter and hotter. Eventually, some of the water near the top of the system, where the pressure is slightly less, will finally flash into steam. This initial burst of steam acts like a plunger, pushing a column of water out of the geyser's vent at the surface. This is the moment everything changes. As that first slug of water is forced out, it instantly reduces the weight and pressure on all the superheated water below it. It's like taking the lid off that shaken soda can. With the pressure suddenly gone, the superheated water, which might be 370 degrees or more, instantly and violently boils. This chain reaction is called a flash boil explosion. A massive volume of superheated liquid water instantaneously converts into an even more massive volume of steam. We're talking about an expansion of over 1,500 times in an instant. This explosive expansion is the driving force that blasts the remaining column of water and steam hundreds of feet into the air, creating the spectacular geyser eruptions we see, like the famous Old Faithful. So when you see a geyser erupt, you're not just watching hot water shoot out of the ground. You're witnessing a powerful natural steam engine powered by the incredible physics of pressure and superheated water. It's a violent, beautiful, and perfectly natural process happening right under your feet. So where did this specific 370 degree Fahrenheit number come from? Is it just a random guess? Absolutely not. Scientists have actually measured it. They use specialized probes and equipment that they can lower deep into the conduits of geysers, like the famous Steamboat Geyser, which is the world's tallest active geyser. These probes have to be incredibly tough to withstand the extreme heat and pressure, but they've sent back data confirming these mind-boggling temperatures. In 1991, a research project at Steamboat recorded a temperature of 188 degrees Celsius, which is about 370 Fahrenheit, just before an eruption. This confirmed that the water deep within the system does indeed reach these superheated states. It's not just a theory, it's a measured and documented fact. It's truly incredible to think about the forces at play. Yellowstone is essentially a lid on a giant, simmering pot. The park's crust is constantly being heated, stretched, and pressurized from below. This is why the ground is literally pulsing. Scientists have measured the ground in the Yellowstone caldera rising and falling by several inches a year as the magma chamber beneath it breathes and shifts. These geysers and hot springs are the safety valves for this immense geothermal system. They release heat and pressure that would otherwise build up to potentially catastrophic levels. So these beautiful features are not just tourist attractions. They are critical components of a living, breathing volcano. They are a constant reminder of the immense power lurking just a few miles beneath one of America's most beloved landscapes. This phenomenon isn't just unique to Yellowstone either. You can find similar geothermal systems with superheated water in other volcanic regions around the world, like Iceland and New Zealand. It's a fundamental principle of geology and thermodynamics. Wherever you have a potent heat source, a supply of water, and a confined underground system to build pressure, you have the potential for this incredible natural display. It's a perfect recipe for a geyser. So, the next time someone tells you it's impossible for water to be 370 degrees, you can tell them about the power of pressure. It's not magic, it's just some of the most extreme and fascinating science on our planet. It turns a simple rule we learn in school completely on its head and shows us that the real world is often far more complex and amazing than we can imagine. So to wrap it all up, can water in Yellowstone really be 370 degrees Fahrenheit? Yes, absolutely. It's not a myth. It's a scientific fact made possible by the immense pressure deep within the earth. This pressure traps the water in a liquid state, allowing it to become superheated far beyond its normal boiling point. When that pressure is released during a geyser eruption, the water instantly flashes into steam, creating a powerful explosion that we see as a magnificent eruption. It's a beautiful and powerful demonstration of physics in action, happening every single day in Yellowstone National Park. It's one of those things that reminds you how dynamic and powerful our planet really is. Thank you so much for joining me on this deep dive into the thermodynamics of Yellowstone. I hope you found it as fascinating as I do. It's a great example of how a simple question can lead to some incredible scientific truths. If you enjoyed this video and learned something new, please give it a thumbs up. It really helps the channel out. And don't forget to hit that subscribe button and ring the notification bell, so you don't miss our next adventure into the world of science. Let me know in the comments if you've ever been to Yellowstone, or if there's another natural phenomenon you'd like me to explain. Thanks for watching, and I'll see you in the next video.